physics video. Yay, we already know that. Anyway, I guess it's just for my sake. So I have been pondering. I found this website a couple of days ago, SuperLaser123. So I'll leave links to 3 videos, I think, that are really interesting. So anyway, what he's done is set up 2 telescopes, with mirrors and laser, and so it allows him to use really big things and create, interference patterns. And intuitively, I say this demonstrates that light's not a wave, because when I play this video, you'll see these pieces are spaghetti, actually end up an inch apart when this pattern gets really reminiscent of the classic interference pattern, in that it gets more and more bars. And I think it would be kind of silly to imagine that light is, the photons are interfering with each other in any kind of, if you did this experiment with just single photons, that you could possibly have this circumstance. That there's any communication between photons in terms of, there's 4 surfaces, so in a sense it duplicates the double slit in that it creates 4 surfaces. But there's just so much to how this experiment's done, and the whole artifacts of the lensing and all the other issues that go into how this is constructed, that I just don't know. I don't have any idea how to interpret it at all. Even to create this bar effect, he had to put a filter in of some kind. Because in other effects he has this, there's obviously nothing being filtered from different directions, and you wouldn't end up with a bar like this. You'd end up with this continuing all the way down the screen. Whatever pattern you had would go all the way across. Just because this light source is now huge, you can kind of see the green lasers hitting, a very large area. So it does go through an aperture, which I'll get to, because that creates its own artifacts that I think are part of this whole thing. So I don't think I have any conclusions yet. Just I'll play some of this, and I'm still pondering it. I know there's I know there's an explanation, and I shall seek to find it. There's just so many elements, there's so many things he throws in front of this thing, and so many times where I'm just saying, oh wow, I wish I could tell him. So I'm going to see if he does requests, because I have a few requests. But anyway, here's the double slit. I'll turn the sound off. Don't need the music. So as he moves them closer together, further apart, you can see you get the tighter and tighter pattern. So as he goes further apart, pattern gets tighter and tighter, and then there's this time when he tilts it a little. See, they're both tilted, and you can see the separation created. So we have 2 surfaces at one angle, 2 surfaces at this angle, and you can see that separation taking place. And that's what I would be curious about, is if you tilted them a lot more, can you really get that to tilt all the way and see what is really going on here. He also has like the focus, I guess, is too bright, so he has a little dot on the focus. But that's the whole problem here, is there is a focus, and I don't know whether that's creating some of this artifact. I don't know. It's just very curious. Very curious. So you can see that this is a huge separation, and you've got a pretty classic pattern. Like I said, when they're straighter, you can really see there. So now they're more straight, and you have the alignment is more perfect. I think that's enough for that video. This diffraction grading one is just incredible. So it's called Diffraction Grading 720p. So you got to see this video. Like, it's all kinds of different stuff he puts in front of this thing, and all kinds of effects. And I've noticed some things that are just that to say something. You know, they're saying to me, ah, there's something. So in this effect, you can sort of see these rings here. That, and it doesn't really matter where he jiggles this, that stays. So that's one thing I've noticed. So this is in the laser light itself. So this is what's happening. So when they use an aperture, you know, a little tiny hole to cone the light for these two slit experiments, this is the light. This is what's really getting thrown at those two slits. This is inside that light, this image. So I don't know whether you could pull that out through polarization or what. I mean, it's obviously in there. So it's kind of like the pinhole camera idea, where you won't get an image unless you have just the right amount of light. And this is just the right amount of light, again, circumstance. So when the light's being diffracted, somehow the light being diffracted is not this pattern light. And so the pattern is revealed because the light being refracted isn't the pattern light, or vice versa, that the pattern light is light more likely to be refracted. So you can certainly argue that polarization would have an effect, that depending on polarization would increase or decrease likelihood of refraction, so that could have something to do with this. But clearly this, in my opinion, this is clearly in the laser light that's being shown on this object. So this that pattern, because that pattern doesn't even move. Like say when he starts to, I'll play a little bit of this, but you can see there's quite a bit of movement in what he's doing, and that pattern won't really go away. See how that pattern just stayed there? So this stayed no matter how much you move this. So this is in a completely different position, and yet that pattern is solid. So clearly the light is not, you know, consistent, without defect, without character. It's not flat. I'm trying to think of the right word for that, but I didn't think of it. So he has this, the Argo spot thing here too. This one isn't quite as interesting. So I guess I won't bother with that. That's a little spot in the middle. Well, the video's going to try to load anyway. Alright, there. So this one's also interesting. Fresnel diffraction at straight edges. So he's just putting a piece of cardboard in front. And you get this at the corner, you get this kind of amazing, you know, where it just wipes the corner out because of the two influences. But again, these bar thing, I would, you know, it doesn't seem to matter the intensity of the light, and it doesn't seem to stretch out much from corner to see. It's just hard to capture. That's why I want to run it slow, just to see exactly what you get, depending on whether you're at the fringe of the light or at the focus of the light. But you can see this is a wide source, but as pointed out, it has its own character that's built into it, and I think the character of that light is what's creating the effect. Like these bars aren't just coincidentally you know, similar in number to the fringes that were created in that light from the focus going out. But these fringes are consistent with that. And so, you know, that's just something else to consider. There's also these weird, this image, the setup is two telescopes, and then he has it, the mirrors behind it, and it shoots it on an opaque or a clear, you know, a semi-opaque screen. And then he's taking obviously the photograph from this direction of the image projected on the back, I believe. But it doesn't really matter. But so you can see artifacts in the image. This is the shadow created by this card being imposed on the imaging place. So you probably should have a divider there just to take out, so you can see the extra light shining through here. So the green is turned red when it ends up on the screen for whatever reason. So you can see he doesn't have a focus here, so he has no pin to wipe out the lightest light, and he has it, obviously it's not a tiny focus, it's a wider focus now. He has a bigger, this has been widened, and it has no intense focus. So obviously for this, this is a different setup in terms of the focus. There you can sort of see it there, where in the two slit example he had the very bright center, and you know, that he had to blot it out just for the purpose of getting a clean image. So he's obviously changed the experiment for this, you know, in ways he doesn't provide any explanation really, which is disappointing. But these, you know, these videos only have tiny view numbers. You know, they're really quite interesting, just visually. But I mean, as a scientific experiment, I think this is quite, I don't know whether he thought of it or what. I mean, it's just really quite brilliant to use the telescopes to, you know, expand the mechanical world you're working with. But again, I don't know how much of these effects are artifacts. But if they're artifacts, it just demonstrates that there's artifacts in the actual two-slit experiment. There's artifacts in all of these experiments that I don't think are being accounted for. And especially in the two, I've always been suspect of the light source in the two-slit experiment, because no one pays any attention to it, as if they know what kind of light they're projecting at the two slits. And somehow, like, it somehow doesn't even matter what that light is, and I think it's critical to the effect. So anyway, it's very interesting, I say, and so I just thought I'd point it out. And like I said, I don't know what to make of it yet. It's hurting my brain, I got to admit. This especially, this is, like I said, this diffraction gratings video will get you wondering. And I'd like to just, he has different objects he puts in front, and like I said, there's a consistency to this pattern that irritates me. You know, where the diffraction all starts from the center focus, no matter where the object is in the screen. The diffraction pattern always is in the center focus, which is strange. You know, the diffraction pattern doesn't move with the object, which seems wrong. I mean, just patently wrong. No matter where you put this, these rings exist. This relationship is perfectly centered. I mean, this little patch of interference pattern and this little patch will always be exactly right on the fringe of this dark band, no matter where this moves. I mean, that doesn't seem right. Right? No, it doesn't seem right at all. Anyway, so you can see in this experiment, like I said, the focus is entirely different than that other experiment where it was wide. Here it's intense. So what's really happening here is I only think a tiny bit of this is actually creating that effect. It's not the whole thing, it's just a tiny bit of it, and just a slight bend in it creates that circle. But anyway, I don't know that for sure yet. So anyway, just very interesting. So if anybody wants to try to communicate with this guy and find out what his story is, I'd be I'm not very good at I mean, I have to, you know, I should just post a comment. No one's even posted comments at all, and just ask him if he does requests, because you know, and I'll think about what it is I would like to see done, just to try to get a grip on this. Very interesting. Anyway, it's distracting, but I think it's distracting in a way positive to my argument, in the sense that with the two-slit experiment, especially with the two spaghetti, it's very hard to make the argument that the photon over here has somehow sent a wave over here, and that the two are communicating with each other. Pretty hard to make that argument. This would be a great circumstance to put a divider right down the middle, and then see what happens. That would be interesting. you know, then now that you have this huge mechanical space to work with. So that would be one of the things I would suggest, is put a cardboard divider right between the two telescopes, right through the focus, and see how that affects the effect. I imagine it will create its own fringe to start with, anyway. But here again, you can see this part of the pattern, I think, is being created by the, you know, the little lensing thing that's going on here. But anyway, till next time.